La historia y desarrollo de las matemáticas.
The fossil remains found in Moraiva and Ishango are proof that hominids have already begun to create a counting system. Both fossil remains are approximately 30 to 35,000 years old. Cro-Magnon man 35 to 20,000 years BC. Without knowing it, they created a canary and decimal system. They used their fingers and stones to count.
Sumerians 3200 BC. His records are captured on clay tablets. They had a sexagesimal system. They used 10 as a unit. They set the circle to 360 degrees, the hour to 60 minutes, and the minute to 60 seconds.
Babylonians 3300 BC. They divided the day into 24 hours. They made important advances in arithmetic, solving problems related to fractions, quadratic equations, and geometric calculations. The surviving mathematical text is Plimtop 322. They had methods for finding approximate square and cube roots of numbers. They solved problems of area and volume of geometric figures. They made tables to predict interplanetary movements and eclipses. Semites 3000 BC. Akkadians, Assyrians and Babylonians arrive in Sumeria. Coexistence of the decimal and sexagesimal system. The sexagesimal system is eliminated. The Egyptians 3000 BC. They wrote the numbers by aligning or accumulating objects. Fractions with numerator 1 are found in their hieroglyphics. They used a decimal base system. They could solve equations, calculate geometric figures, and draw spatial figures. They advanced considerably in the use of the application of geometry by calculating the area of the triangle, rectangle, trapezoids, orthohedral cylinders, and pyramids. The Greeks 600 to 370 BC. Euclidean geometry. Euclid is a Greek mathematician who wrote the book The Elements, establishing the axioms and rigorous proofs that are the basis of geometry as we know it now. Pythagorean theorem. His theorem of right triangles is one of the pillars of geometry. Archimedes of Syracuse. I apply mathematics to floating bodies. He established the geometry of optical reflection. Tales of Miletus. The scientific study of geometry begins. Greek theory of irrational eudoxis. The Indians 500 to 876 AD. Aryabhata introduced the concept of zero. The Indians had developed a decimal measurement system. They developed a system where they could make 90-degree angles perfectly. They used arithmetic rules to calculate. They accept the use of irrational numbers as correct solutions. Solved linear and quadratic equations. They created methods to solve Diophantine equations. The Arabs 776 to 830 AD. They used a Siddhanta method of calculation in addition to trigonometry and astronomy. It was possible to perform all numerical calculations using only 10 digits. They contributed to the completion of arithmetic algorithms, the development of algebra, and the extension of geometry. Europe, Italy 1170 to 1250. Leonardo of Pisa. He introduced Arabic numerals to Europe with his book Liber Abaci. Creator of the Fibonacci sequence. He introduced novel methods for solving linear and quadratic equations, problems related to arithmetic and geometric progression. German Hanseatic League, 1453 to 1789. They are attributed the calculation of the first trigonometric tables. The first book on trigonometry common mathematicus. I contribute to the development of number theory in the context of continued fractions and approximation of rational numbers. Denmark and Scotland 1568 to 1617. Tycho Brahe introduced applied mathematics to astronomy. His measurements laid the foundation for the work of Kepler and others. Scotland. John Napier. He invented logarithms. Calculation of the first tables of logarithms, base 10. Holland 1630 to 1644. The connection between algebra and geometry is discovered. The modern coordinate notation by Descartes bore fruit. Frans van Schoten. He interpreted and disseminated Descartes' analytical methods, which made the use of Cartesian coordinates popular and laid the foundations of analytical geometry. 1801. Methods to find maximum and minimum values of a function. Disquisitions arithmeticae. Research in arithmetic. Important contributions in statistics. Carl Friedrich Gauss. He showed that every positive integer can be decomposed in a unique way into the product of prime numbers. Theory of congruences differential geometry. Special elliptic and hypergeometric functions. Least squares method. Fundamental theorem of algebra. Niels Henrik Abel 1802–1829. I study the structure of sets. I study 5th grade algebraic equations. He made significant contributions to the study of elliptic functions. He introduced concepts such as generalized power series and developed methods for the evaluation of definite integrals. George Cantor introduced and developed the concept of infinite sets. Development of the theory of cardinality of sets. I contribute and develop the application of the Fourier series in mathematical analysis. He discovered the paradox that there are sets that are infinite but have different sizes of infinities. Peano. He is the inventor of the signs that represent set operations. Peano is primarily recognized for his axioms for natural numbers and his contribution to the formalization of mathematics, laying the foundation for the later development of mathematical logic and the foundations of modern mathematics. George Boole established the concept of algebraic logic in mathematics and simplified the world into basic statements that had a yes or no answer, using binary arithmetic for this purpose. He is primarily recognized for his development of Boolean algebra and its application to formal logic, laying the groundwork for digital circuit theory and having a profound impact on areas ranging from mathematics and computing to philosophy and epistemology.
Se cree que los primeros sistemas de numeración se originaron en las antiguas civilizaciones de Mesopotamia y Egipto, alrededor del año 3000 a.C. Estos sistemas iniciales consistían en representaciones simbólicas simples en cantidades y medidas. Posteriormente, los números y los sistemas de numeración se desarrollaron y evolucionaron a lo largo de toda la historia en culturas como China, India, griega y romana. La numeración indoarábiga se originó en los siglos VI después de Cristo. Esta numeración actualmente está en nuestro sistema de numeración y se introdujo en Europa en la Edad Media a través de la influencia árabe. El concepto del cero como número significativo también se desarrolló a través del tiempo. La creación del cero permitió que se desarrollaran matemáticas más avanzadas y las matemáticas que actualmente tenemos.
La noción de los números en los niños es un aspecto fundamental en su desarrollo cognitivo y matemático. Los niños comienzan a desarrollar una comprensión de los números desde una edad temprana, a través de experiencias cotidianas y actividades de aprendizajes estructurados. Aquí hay algunas etapas claves en la adquisición de la noción de los números en los niños. Correspondencia 1 a 1. Los niños pequeños comienzan a asociar números con cantidades reales a través de la correspondencia 1 a 1. Por ejemplo, emparejar un número con un objeto físico. Conteo. El conteo es una habilidad fundamental en el desarrollo numérico de los niños. Aprenden a recitar los números en orden y a asignar un número a cada objeto en una colección. Cardinalidad. La cardinalidad se refiere a la comprensión de que el último número contado en una secuencia representa la cantidad total de objetos en una colección. Por ejemplo, al contar una fila de juguetes, el niño comprende que el último número dicho representa cuántos juguetes hay en total. Comparación de cantidades. Los niños comienzan a desarrollar la capacidad de comparar cantidades y entender conceptos más grande que, más pequeño que o igual a. Operaciones básicas. Con el tiempo, los niños comienzan a comprender y aplicar conceptos de suma, resta, multiplicación y división en contextos simples. Es importante fomentar el desarrollo de la noción de los números en los niños a través de actividades lúdicas y educativas que promuevan la exploración, el razonamiento y la resolución de problemas numéricos. esto sienta las bases para un sólido entendimiento matemático en etapas posteriores de su educación.